Okay, so I want to show you a couple of rules that you need to know for secant and tangent and antiderivatives. If we want to find the integral of secant squared of x, think about what you take the derivative of that will give you secant squared and its tangent. I just wanted to make sure that you had remembered that one. Another one is the integral of secant of x. Now, there is a process that you can use to find this antiderivative. What you do is you end up having to multiply by a factor of 1, and it's secant plus tangent on the top and the bottom, and you use substitution. But what I will tell you is that what you would get when you take the antiderivative will be natural log of secant x plus tangent of x. And then there's another rule, the integral of tangent of x. Again, if you change this one to sine over cosine and then do use substitution, if you change it to sine over cosine and then do use substitution, you would get negative natural log of cosine of x plus c. So these are three rules that you need to know, and I want to do just a couple problems to show you how to use those three rules to find the antiderivatives. So first of all, let's say we wanted to do the integral of tangent of 3x. Basically, we know the integral of tangent is negative natural log of cosine, but we need to use u substitution. U is 3x, so du is 3. 3 in, 1/3 out, that means we've got 1/3 integral tangent of u. And again, we know the integral of tangent now because we have that rule there. So this is going to be negative 1/3 natural log cosine of u, or cosine of 3x. So it's just knowing how to use those rules and use them in terms of problems we already know how to solve. So let's look at the next one, x secant of 2x squared. We know the integral of secant, so again we're going to do a u substitution with 2x squared. That comes out to be 4x, so we're missing a 4 and a 1/4. So that would be 1/4 integral secant of u. That's one of our rules. The antiderivative of secant is natural log of secant of u plus tangent of u plus c. Okay, again we're going to use u substitution on this one. It's kind of complicated on the process here as far as what we're going to do, but we're going to let u be the bottom. Let's think about the derivative of tangent. Well, the derivative of tangent is secant squared, so this is going to be 2 secant squared of 2x. Notice we have everything but the 2. I'm going to take that 3 out, put the 2 in, and also put a 1/2 out. So really we have a 3/2 out here, integral 1 over u, which we know the antiderivative of 1 of u is natural log, so 3/2 natural log of u, or tangent of 2x. So the rules are just the same as everything that we've been doing, just in a different format. Okay, so let's look at number 4 very quickly. Again, u is going to be secant of x squared. And then the antiderivative, or the derivative of secant comes out to be secant tangent, which is there. And we've got this x squared, so that'll be a 2x. 2 in, 1/2 out, so we've got 1/2 integral 1 over u. Again, we get a natural log. You do not need to memorize these formulas, just be able to use them along with the derivative formulas as well. So I just wanted to make sure that you were aware of a couple of those kinds of problems.